Alright, welcome to the video. In this video, I'm going to be going over the law of cosines, and we'll be looking at using the law of cosines to solve a non-right triangle that doesn't fit for the law of sines. So again, we really want to use the law of sines, but if we don't have the use of the law of sines, so if we don't have the capability of using law of sines to do sine of A over A and sine of B over B and so forth, then like if we can't get one of these ratios to happen, then we're going to end up using the law of cosines. So let's see what happens here. Let me give you the law of cosines. I'm not going to go over exactly how it comes about, but basically we end up using the Pythagorean theorem to come up with the law of cosines. So that's why the law of cosines looks a lot like the Pythagorean theorem. So the law of cosines is this. We have a squared equals b squared plus c squared minus, notice here that this part looks a lot like the Pythagorean theorem, minus 2bc cosine of angle A. It's actually, I mean, it looks like a lot, but it's actually pretty easy to remember the law of cosines. We can use the law of cosines for any side that we want. Side A, this is what we would have. Side B would look like this. B squared equals, instead of B and C, we're going to have A and C. A squared plus C squared. Minus 2, instead of B and C, we're going to have A and C. And then this angle always matches up with the side, so cosine of B. We can also use C squared. So instead of AC or BC, we're going to use, that's right, B and A. Minus 2, you're getting it, BA times the cosine of C, that's right. So we can use this, this is the law of cosines, and we would just plug it in the formula really and solve. But again, I just want to make sure you understand that if we cannot use the law of sines, we'll use the law of cosines. And a couple of things to note, only use the law of cosines once. So use law of cosines once. Once you have an angle, the included angle that you need, or the side that you need, then you're going to be able to use the law of sines. So then you go to the law of sines. The other thing is that if you don't have any angles, you always want to find the largest angle first. And the reason we want to use the largest angle first is it has a lot to do with the boundaries for cosine and sine, but we're going to see that later on in the next unit. So just find the largest angle first. How do you know if it's the largest angle? Well, remember that the largest angle is going to be directly opposite the largest side. So whatever the large side is, that's the angle that you're going for. All right, so let's take a look at two examples of using the law of cosines. And I'm going to try to run through as quick as possible. These are kind of long process, but I'll go through as quick as possible. So let's take a look at two examples. All right, here's our first example, and I'm going to go and label my triangle here. So angle A is 68 degrees, side C is 5, and side B is 8. So notice if we tried to set up the law of sines, we wouldn't be able to. So let's go ahead and find side A here first. We're going to use a law of cosines, and remember it's A squared equals B squared plus C squared minus 2BC cosine of angle A. So A squared, we have B is 8, plus C is 5, minus 2 times 8 times 5. Again, folks, this is just a formula, so you're just plugging in everything you know into here. All right, then we're going to have A equals the square root of all of this stuff. And then I'm going to go to my calculator and enter this into my calculator. So using my TI Inspire, I can actually put in the entire thing just as it says here. So square root, and I could throw it in there, and I'll get 7.68. All right. And if you're not using the TI Inspire and you're using something else, I suggest that you multiply this stuff here first, and then do the 8 squared and the 5 squared, subtract them, and then do the square root. So take it a little step by step there, so that way you don't miss them and put them in the incorrect order. All right, so now once you have this, now you can set up a law of sines, because you can go sine of A, so you can go sine of 68 degrees over side A, which now we know is 7.68, equals, let's see, what do we need to find? Well, we need to find angle B, so let's go ahead, sine of angle B over 8. All right, and then we'll cross multiply this and solve for the angle. So we'll have sine of B equals 8 sine of 68 degrees over 7.68. And then we want to find this angle, so to find that angle we use the inverse sine. Okay, so then we're going to plug that in our calculator. And so we're going to plug that in our calculator and see what we get. And that gives us about 74.97. So we'll say that angle B is 74.97 degrees. Okay. And then to find the last one, we just take 180. Okay, so we take 180 minus 74.97 minus 68, and we get 37 degrees. So we'll go ahead and put that there, 37 degrees, 37.03, and there we go. Okay, we got it. So we first use the law of cosines, then after we found the necessary information, we use a law of sines. So let's take a look at one more example. And in the next example, we have a side situation. So what we're going to have to do in this case is we'll label these here real quick, A, B, C. We're going to have to find the angles because we know all the sides, but we don't know the angles. So in this situation, whenever we have side, we're going to want to start with the largest angle. We always want to find the largest angle with cosine. And again, it has a lot to do with the restrictions on cosine and sine, and I haven't gone over that quite yet. We'll talk about that a little bit more when we talk about the unit circle and we talk about some other inverses and things like that later on in the next unit. But for now, just remember that you're going to use law of cosines for the largest angle. So in order to find the largest angle, you're going to locate the largest side, which in this case is C. So we're going to find angle C using the law of cosines. All right, so what I'm going to do here is I'm going to go ahead and plug everything in. So we've got 12 squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of C. Now we're looking for C, so what we're going to have to do is we're going to have to isolate cosine of C. So we're isolating this. So in order to isolate that, I need to subtract 7 squared and 9 squared from both sides. Now if you wanted to, and you wanted to do this out and kind of calculate all this stuff out first before multiplying it and dividing and solving for cosine of C, that's fine. You can do that. I'm just trying to show you what the algebra here is for this. Okay, so now divide everything by -2 times 7 times 9. And I'm going to get cosine of C. Remember, to find angle C, we need to use the inverse cosine. So angle C is the inverse cosine of 12 squared minus 7 squared minus 9 squared over -2 times 7 times 9. And we will enter that in our calculator and see what that gives us. So let's go and bring up the calculator. That gives us 96.4 degrees. So that's our angle C. Once I have that figured out, then I'm going to go to the law of sines. So now we have this angle here. Okay, now we can use the law of sines. So we're going to go sine of C over C equals sine of A over A. And we're going to find out what A is by using the inverse. So I'm going to multiply here. So 7 times sine of 96.4 degrees over 12. Okay, and I kind of did a lot of simplifying here all at once. I cross multiplied, then I divided by 12, then I did the inverse. So let's go and see what that's going to give us. 35.4 degrees. So we've got A now, 35.4 degrees. And we want to find all three, so we're just going to add these up and subtract 180. So 180 minus 35.4 minus 96.4, and we get 48.2, and that is all. So I know it's kind of a lot of work, but it's really, you know, it's basically hopefully straightforward for you. And those are two examples of the law of cosines. Okay, good luck.